NACOS noun is kind of a unique privilege, and I'm happy to share my experience here. So, actually, no amount of time that is given to me can be enough to actually, explain everything about machine learning. But I'll be as concise and precise as I can be. So, I hope you all can follow me as we go into the machine learning aspect.
Yes.
Okay. So, straight to the point. Now, machine learning is all about now in machine learning, the most important thing we need is data. That's the number one thing in machine learning. In any machine learning aspect, the first thing is data, which is why I'm so happy when my the other presenter gave a very perfect presentation about data. In fact, I'm blessed also, and I learned a lot from him. Now, the first thing you do is you gather data and you now apply intelligence on that data. Those the intelligence you apply on this data is the models, the machine learning models, the algorithms that you apply on this data is called intelligence in computer terms. Now it automatically solves your problem. So we go into the problems solving as we are moving forward. Now, this is just a step where you collect the data, you clean the data, and you process it. Now, your data can be in form of primary and secondary. What I mean by primary data are data that they are not preprocessed yet, they are not cleaned, they are not cleaned yet. As we all know, machine does not understand go and do something, or maybe you should just say go and do something. They only understand zeros and ones. So which means when you collect an unstructured or structured data, you have to still clean it using some paradigms actually. You pre-process it. It is called data pre-processing. So you pre-process and clean it into a machine learning understandable language. That is when you now feed your algorithm and your algorithm learns on it. Then it will now give you the proper output you are expecting. Then secondary data are data that are already pre-processed. They are already cleaned. So you can collect secondary data from various companies. Depends. We have data science companies all around the world, and we have data science websites where you can download your data depending on what you're working on. If you are such a person that likes to work on something that nobody has worked on before, even if that is not possible, yes, it's possible you can work on something probably not too many people has worked on it before. So you have to collect your own data, make it primary data and prepare it. But if you want to improve on someone's probably work, then you collect a secondary data and you just feed your algorithm, then you try to improve the person's work. Please, are we following, please?
Yes, sir.
Yes.
Yes.
Okay. All right, sir. Okay, sir. Okay, sir. Um, Now, this is traditional methods and machine learning methods. Traditional method, I mean, colloquially, the things we used before. Technologies now, they are something that is we are evolving.
Yes,
What
sir.
we are
Go
using
ahead.
right now okay, what we are using right now in this century is not going to be what they are going to use next century for sure. In fact, in the next 10 years, we will be looking at another era of technology. So, which means this one will be an old aspect again. So, before, colloquially, they use if then rules, a lot of rules. So, I make a use case here, an example. I say spam filter as a case example. This is a diagrammatical workflow of spam filter in traditional approach. Now, what they do before is we study the problem, then we write the rules. And these rules are if then rules. They are if then rules. For example, your spam filter. Let's say you want to know if a message, an email is spam or ham, that is non-spam. So which means you have to detect some words there to know if the spammers, spammers also, according to, probably, as I'm taking it here now, I want to believe that these spammers also are computer oriented. For example, all these your hackers, these that just create spywares and just send it to your system, and you expect your system to detect if this is a spyware or not. These people are also computer oriented, so they will know that, okay, you are trying to elude them, you are trying to block them, so they will change their method. They will change their method. See, they might change it from you writing FROM as 4RM as FROM UR. Then the system will now fail to fail at this test because the rules will not contain the change of the new word. So you have to now come again and start writing another if then statement. Can you imagine how hard that will be? Now, if spammers continue to create a workaround for each blocked words of spam filter, we will now keep writing rules forever. So, which is why there is a more and better approach to that traditional. So now we are looking at a diagrammatical workflow of ML approach, machine learning. Now, machine learning models, when you hear machine learning, just know that they are set of algorithms, they are set of paradigms, they are set of models. All they need is data, just like I said the other time. The brain. The brain is what gives you the essence of, wait, okay, this is you. This is what I'm doing. It's your brain that tells you, okay, this is what we are doing right now. This is who I am. Without the brain, there's nothing like human being. Without the brain. You've studied, you train the ML model or algorithm with data points. After you evaluate, you launch. If there are still some errors, you go back and study the problem very well. Then the problem, after you study the problem, you train the model again, depending on how satisfied you can be, you now be. Then after that, now compare these to those kind of traditional way. Something that now you are just training the model with data that you've gathered. The only problem you're having here is collecting data and pre-processing it. After you've done that, in fact, you're in perfect shape. All you have to do is just train your model with that data. So the main problem about machine learning is the data, because the data will define the model's performance. That's just it. As the brain is determining our own performance also. It's as simple as that. How brilliant we are, how sharp we are is defined by our brain. And what defines our brain? It is the data, the infos we receive. That's what define us. That is what define our brain. So in machine learning also, all these models are defined by data and how clean is the data. Okay. So the advantages of ML over traditional is: number one, it observes which words and phrases are good predictors of spam. Now, this time around, it's not as if someone will just write, okay, FROM, F4RM. It will detect itself what kind of which words are good predictors of spam in an email. Now it detects unusual, frequent patterns of words. Then also the program will be much shorter. It will be easy to maintain. It will be more accurate because it is not more of coding. It is more of data. It is more of data. It is not more of coding. So your program will be much shorter. It will be much shorter for sure. You are not coding if then you are not doing. You are only training. So your program will be neat. It will be much shorter and it will not be complex because you know what you're doing. All you have to do is get your data and understand the kind of model you are using because we have several machine learning models. So, and to choose a model, it depends on the kind of problem you are solving. We get there. Now, bring whatever spam you want to do, it will detect it. And even if it does not detect some, for sure it's a lot of spam. If your model is, let's say, 90% accurate, then I mean you have won. Because traditionally, if you look at the statistics, in fact, you can't get 40%. How many times do you know you're going to write if then rules? So let's continue. Now, this now more this another grammatical workflow in which the intelligence is improved. This time around, it's an automated ML whereby your model is now online. So this time around now, it's not local again, it's online. So it will be updating itself depending on data points given. It will be updating itself. It will train the ML, evaluate, then launch. So each time it receives email, it will be updating the data because it will be taking it as data and it will be learning on it, it will be training on it. So this is another should I say help that it does for us. Now it helps women learn and gain insights. On a normal ground, as I said, like my the other presenter said, data analysis gives you a lot of insights. And when you're training an ML, in fact, during your training, you'll be seeing a lot of because there are some paradigms in those MLs that would show a lot of insights for you. In fact, the relationships and the correlations that you're not seeing before, you'll be able to see it. You'll be able to see it. It will be pasted on your system, and you'll be graphically using Sorbonne or Pandas or your NumPy. You will see some of insights in which you will gain, and you will now understand the data itself. That is things that I love about machine learning. Bring your data, clean it, feed it. The insights you will gain, the correlation and a lot of relationships that you're going to see. In fact, you'll be surprised. Now, please, are we following, please?
Sure.
Yes,
Yes,
yes.
sir.
Yeah. Thank you very much. Thank you very much. Uh, Categories involved in machine learning. Now, we have three basic types. Actually, it's four, but there are three basic types: supervised learning, unsupervised learning, and reinforcement learning. The fourth one is semi-supervised, but it's not being used. It's so we are based we base on supervised, unsupervised, and reinforcement. And in supervised learning, we have classification and regression. Classification and regression. In in supervised learning, we have classification and regression. In unsupervised, we have association or clustering. Then in your reinforcement learning, we have agent-based learning. Now, we are on supervised learning now. Now, in layman's time, supervised learning is whether or not most students are engaged in the learning. You teach the model what to output during training. Now, let me recapitulate. I said a machine learning task that infers a function from labeled training data consisting of a set of training or learning examples. Now, in supervised learning, as the name implies, during training, you give the output of each data point. I'm going to make an example. Okay, let's say good. The example here is email again, using spam or ham. Now, for example, we want to train an ML to detect if an email is spam or ham, that is non-spam. Now, for each predictors of these spam mails, the data will be of a labeled. Your data will be labeled. Okay, let me make another example that will be pretty much easier for what I'm saying. Let's say cat and dog. You want to build a model that will be able to detect if an object is I'm trying to use an object here. If an object is dog or cat. Now, what are the first things that you get? What are the first things that you get if you want to know if something is a dog or a cat? You get the attributes, right? The attributes of
Yes.
dog, you get the attributes of cat, isn't it? Those are called predictors.
Yes.
Those are called predictors. They are called the attributes. Now, for each predictors now, you have samples. These samples are the one, they are on the rows. The attributes are on the columns. This is how a data looks like. I should have made an example. I should have drawn an example here. This is what a data looks like. Your Excel spreadsheet. On the columns, let's assume for cats, you have probably the sound, right? That's a very good predictor of a cat, the sound. Then your dog barks, your cat whatever it does mews, right? Now, let's say we are just considering that for the attribute. We are considering just one attribute. You know, you can consider as many attributes as you can. You can consider as many attributes as you can. So, but we are considering only one attribute now, which is the sound they make. Your dog barks and your cat mews. So now, on the rows now, you have, okay, this this dog, this probably dog A. I mean, let me say object A rather, not dog A now. Object A. In the column of back rather, in the column of back, you put 0. In the column of mew, you put 1. Definitely that label will be what? I mean, the target will be what? I don't think you guys understand me.
I don't understand though.
Okay, let me come again. Sorry. I said
Again, we don't
we are
understand
considering
that.
one. Okay. I'm saying now your dog and you are building a model that will identify a dog and a cat. Now we are considering only one attribute, which is the sound they make. The sound they make is the attribute we are considering. Now, on your spreadsheet, I said the columns will be the attributes. The columns will be the attributes. So, which means on the first column, you said you wrote back. On the second column, you said you wrote mu. You understand now? You wrote mu on the second column. So for the first, on your row now, for the first sample you are giving,
Yes, sir.
under column A now, you wrote 0 there. Under back, you wrote 0. But under mu, you wrote 1. What does that imply? That implies that sample is a cat.
For cats, yes, for sound.
Yes, exactly. Thank you very much. That implies that sample you are given is a cat. Now, let's go to number 2 sample now. Under dog, you wrote 1. Under cat, you wrote 0. What does that imply?
Implied the
That it's a dog.
dog, yeah.
Exactly. That is how data look like. Under each predictors, there will be values. These values will equate to a target. So whatever target you are giving it, the model will learn on it. It's just like saying when we were in primary school, we said, okay, 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Now, we were taught all those things and we were taught how to get there so that when we want to add 9 plus 9, we will know how to arrive at the answer. Our teacher is teaching us. That is what you are doing model here. When you are saying cat is 0 here and dog is 1 here,